In the last section, we looked at data and thought about whether the data represented absolute quantities or relative quantities. In this section, we're going to look at a different comparison of data. Are the data we're looking at categorical or quantitative? This is like a second dimension to the way we're categorizing our data. So let's start with categorical data. Categorical variables, and when we say variables, we're just talking about what our data stand for. Think about it as a column in an Excel spreadsheet. Categorical variables are variables whose values represent names or labels. Right? They're in categories. Sometimes these are called qualitative variables. I like the term categorical because qualitative sounds a lot like quantitative. And so it's easy to get them mixed up. So categorical variables are what we're going to call them, and they represent different categories. So let's look at an example. The data we pulled from my Duolingo progress in Russian is our example. This is an example of a categorical variable. The variable itself is the strength. The values of this variable are still strong, pretty good, time to practice, or overdue. Notice what we've got here are the values of the variable are not numbers, right? They're categories, right? And I've been calling them categories. So how do we quantify and analyze categorical variables? Well, that's where frequencies come in. We can look at frequencies, as we saw from the beginning. 1,908 words are in the still strong category, for example. We can also make those relative frequencies. That's what we did in the last video you watched. So frequencies are how we categorize how we quantify and analyze categorical variables. So I can take a look at this category, at this variable, and see the vast majority of my Russian words are in my still strong category. Although there's a considerable amount that are overdue, and the decision I might make is maybe I should go back and review those words. Now let's turn to quantitative variables. Quantitative variables take on values that are numbers. This is what we typically think of as a variable. So let's look at an example of a quantitative variable. Baseball provides us a lot of great examples. And we're going to come back to baseball data from time to time because it's very rich it's a very data rich area. So let's take a look. This is just a general baseball statistics website hosted by the Major League Baseball. And here we have a number of players, the team they play for, and then a whole bunch of different variables for data. So we're going to let's just look at one example. Michael Brantley, he's the left fielder for the Houston Astros. G stands for games. What's nice about this website is if you hover over the label for a variable, it explains what the variable is. This is the games in which a player has appeared. In this case, Brantley has appeared in 98 games this season. This is the 2021 season. And we have others at bats, how many times they've walked up the bat, runs, hits, doubles, triples, home runs, runs batted in. All of these are examples of quantitative variables. So for a game, we'll focus on games for just a moment, the number of games in which Michael Brantley has played. Brantley's played in 98 games. We could categorize these as few, some, a lot. Those could be the values this could take, but instead the values are the actual number of games. So this is a quantitative variable. In fact, all of these are quantitative variables. What's an important, so we saw with categorical variables, what we typically do is we record their frequencies with their relative frequencies and use that for analysis. With quantitative variables, we can actually do computations with them. We can do mathematical things with them. So and over here, these last four columns are examples. So let's look at this one, batting average. I've actually sorted this list by batting average, and to date, Brantley's got the highest batting average in MLB for the 2021 season so far. Season's not over yet. Well, what is the batting average? This is the rate of hits per at bat. So it's a numerical comparison. We divide, if you take a look at the formula beneath that, H over AB. H is the number of hits, and there's a careful definition there as to what counts as a hit. AB is at bats, number of trips to the plate, and notice there's a careful definition there as well. So H over AB is H divided by hits divided by at bats, in this case 124 divided by 383, and the answer is 0.324. What you could do is you could call that a percentage. You could say 32.4% of the time that Brantley has been at the plate, he scored a hit. Baseball's convention is they list the batting average as a decimal. Sometimes you hear the phrase batting 1,000. That would be as if this decimal were 1, because we've got the three decimal places here would be 1.000, and they'll just call that 1,000. So batting 1,000 means every time you're at the plate, you score a hit. But in more colloquial terms, you might hear it as everything you do is a success. For example, there's a movie called The Insider. I love movies where somebody is challenging the tobacco industry, and they're talking with somebody else who is very skeptical of taking on a legal case against the tobacco industry, saying they bat 1,000 every time, meaning they win every case every time they're sued. Anyhow, there's a whole bunch of others. On base percentage, slugging percentage, on base plus slugging. So I will go ahead and put the link in Canvas, and you can play around with this if you'd like to see some more. The key point here, though, is these variables, the values they take on are numbers, and when the values are numbers, you can do mathematical computations with them. One caution is that just because a variable is given numerical values that looks like a number does not necessarily mean the variable is quantitative. If the number is simply code for something that would be a category, which would be labeled by a word or a verbal label, then the variable is categorical. Let me give you an example. Zip codes. Zip codes are numbers. For example, Big Rapids is 49307, but those numbers are codes for a region in the country or in the state. And that region is a label, a category. So it can be sometimes tricky. Here's how to think about this. Does it mean anything to average zip codes? If I add 49307 to, say, a zip code in Kalamazoo, 49008, and take their average, does that mean anything? No, it doesn't mean anything. So therefore, this can't be a quantitative variable. It should be categorical. In the next video, in the next section, we're going to go on and take a look at how having quantitative versus categorical variables impacts the choice of graphs and charts that we might use to visualize their values.